Okay, factoring, here we go. So, first things we're going to look at, the things we should be able to factor, okay, we're going to start with quadratics. Wow, and I started with QUD. Okay, so quadratics. There you go, okay. Sometimes my brain gets ahead of my hand there with a pen. Okay, so quadratics, right, or trinomials, right, is another way to think about them, which is weird. We call them quadratics and trinomials because quad, I feel like, means 4, but trinomial means 3, so I don't know why that is. I don't know. It's a thing. Math, right? We're not English teachers, we're math. All right. And so we're just going to jump right in, okay, with some real basic kind of examples here, just to make sure we can do this kind of stuff, right? So our directions here are to factor, okay? Factor, that's the idea. All right, so we'll start with something nice and easy. Nice and easy. All right, x squared minus 6x plus 8. We're going to go to factor this thing. Okay, so I don't know, there are like different kind of strategies taught, but they all are kind of related and similar and stuff, so I don't know, for you guys, maybe what you do. Does anyone just do guess and check? Does anyone just do guess and check? So Nate, you just do guess and check. That's the way I was taught it back in middle school when I first learned to factor, I think. It was like, just guess and check, okay? Just think of two numbers that multiply to make this and add to make this, and then kind of figure it out.
Yeah. That's how Miss Piccola taught us, and that's kind of still how we do it in my head.
Right. Well, and so in a case like this, I feel like you kind of have to guess and check, because there's no, you can like write your factors out. So you can say, all right, like 8, you can get 8 by doing 2 and 4, or a -2 and -4, right? Or 8 and 1, or -8 and -1, right? And so then which set of these factors add together to make -6? It's these two, so it's like x minus 2, x minus 4. And there's your answer, right? There it is, factored. And so these are equivalent statements, right? They're both saying the same thing. X squared minus 6x plus 8 is the same as saying x minus 2 times the quantity x minus 4.
So on like a test or on the AP test, if we ever get an answer down to where it can be factored, should we factor it?
I mean, if you need to like further simplify it or to do further work with it, then yeah, you should. But if it's I mean, again, it depends on what's kind of asking for there. I guess I'll kind of like maybe.
So if it says like simplify this, I want to get it down to factor.
So yeah, like. The biggest thing, I guess, factoring, one way I can see factoring kind of figuring into things, okay, is, for example, just like simplification's sake, right, or for like trying to match your answer to what's on a multiple choice, okay, right? So, for example, if you see that something that you get factors, but you're unsure, and you go to like look at the multiple choice and your answer's not there, then maybe you need to factor it to see if something cancels out and then will match up with the multiple choice or something. So that's what we need to be comfortable with there, okay? All right, so that's the easiest step, right, when we have a 1 for our, lead coefficient there. What about, though, if we have something like 2n squared minus 13n plus 6? How about that? Okay, so here, again, you could guess and check, and that's what I was taught is, you'd guess and check, but there's another alternative method, right? So, do you guys do the one where you do like 2 times 6, the product sum? Yeah. I think so. 2 times 6 makes 12, right? And then you want to think of two numbers that multiply to make this 12, but add to make -13. So it's like, all right, what do you multiply to make 12? Well, so 12 could be, 3 and 4, or -3 and -4. Obviously, those are wrong, right? 3 plus 4 is 7. I want -13. -3 and -4 is -7. No good. Let's try, I don't know, -12 and -1. What do you know? -12 times -1 is 12, and they add together to get -13. Okay, right? And then what's the next thing we have to do? So, well, we, let's see here. We want to rewrite, I like to rewrite this first. So, whoops, and I don't want to put parentheses around, sorry. 2n squared, so that minus 13, and we break that up, don't we? We write like minus 12n, and then minus 1n plus 6, like that. No? So what do you do at this point? All right,
I think it's easier do like, you would do x squared minus 13n plus 12, and then you factor that, and then you divide by 2.
Okay, I see what you're saying. So, like, did you slide and divide? Is that what you called that, or something like that? That's a thing that I've heard before.
The trash method.
The trash method? Okay. All right. We'll all right. Mac, I know what you're talking about. I'll go over that one after we do this one. Okay. It's gonna be. Again, it kind of works out in a similar fashion. Well, we'll work out the same answer. Anyway. All right. So what do we do here then is we now we split up this term. We can now factor by grouping. Okay. So 2n squared minus 12n. All right. What can we factor out of that for those first two terms? 2n. 2n, right? So 2n. We're left with n minus 6, right? And then what can we factor out of this here? -1. Yeah, -1 is what we want to factor out. So we're going to leave a minus, I'll put a 1 there, and then so it becomes n minus, yeah, very good, minus 6. Don't forget, when you factor out a -1, both things get divided by -1. And so now we see that we have this common term here of n minus 6, so we can then factor out of both those terms. And so we have n minus 6 times the leftovers of 2n minus 1. Right, and so then it's factored. You notice that? So have you just done guess and check then, Caleb? Okay, so do you see how it works? So again, you break up the middle term, and then you can factor by grouping, and then you should end up with a common factor like this, and then they can factor up. Okay, now the trash method, which is an interesting name for it.
Is that like in the book that he made it up?
Who's the teacher? Oh, okay. I doubt he made it up. No one. I mean, I'd be impressed if he made that up. But anyway. All right. Here it is.
Mr. Bingham has his own theorem.
Okay, I believe he stumbled upon it. Yes, I'll believe he stumbled upon it one day. Yes, because I had a student teach this to me one time. I was teaching at a program over the summer at McDaniel one time, and the student was like, "Oh yeah, slide and divide." I'm like, "Slide and divide? What is that?" And so this is your trash method, though. So you do the 2. Yeah, I'll show you. You bring the 2 over here. You slide the 2 over, and make it n squared minus 13n plus 12. Okay, and now this we can factor kind of using our normal product sum method. You think of two numbers that multiply make 12, add to make negative 13. So that would be n minus 12, n minus 1, right? But then you divide the
12 and 1 by 2.
You divide both by 2 like this?
No. Just
right. Okay, sorry, hang on, you're right. You divide, okay, I see what you're, hang on, I gotta rewrite it now.
Under the 12 like a fraction.
Yeah. Like, under the 12 like that, under the 1 like that. Right, okay. 12 divided by 2, we can simplify, it's 6. 1 divided by 2, we can't simplify, so this 2 comes back in front of the n, for some reason, magic, and it becomes the right answer. Slide, divide, and slide back. It's trash, that's right. But it works. And I'm not sure why it works, but it does work, that's right.
Hey man, if it works.
Right, it's
I will probably
witchcraft.
always factor the way Mr. McCall taught me, and it was just to think about
actually,
it
sorry,
really,
I
really
don't
hard in
know.
my head until it worked.
I want to have you guys try one here, and I started to scratch this out, but here, you guys try one now. So try this one. It's going to be 6x squared. 6x squared minus 13x plus 6. Okay, so give that one a shot. 6x squared minus 13x plus 6. And I'll do it as well.
actually like that. I like that.
I think it's trash. I think it's horrible.
Because it's trash.
It's horrible, which makes it trash.
You don't like it because it's trash.
It's horrible.
It's very...
What? No, that method doesn't
You don't divide by
work.
6. Or with
Because this 6 is up
Yeah,
front. You have to divide by 6 and this.
Every time.
You know, it does work every time. It does work every time. If you do it correctly, it works every time.
Alright, maybe I did it wrong.
Here, I'll do
You
that.
literally just take the front number and times it by the last one, and then factor it,
Yeah.
and then make sure you divide by the same number.
Except it doesn't simplify when you divide by 6 again.
Yeah, it does.
Yep, so here, watch.
Simplifies to-
Okay, so you simplify it and then, yeah, so this does simplify. 4 6 is really 3 halves. So the 2 then slides back out front.
Oh.
So the denominator slides back out front. So 2, this simplifies to, what is that, 3 halves. So again, 2 slides back out front.
It should be
Okay.
3x minus 2.
I can't.
be 3.
The first one is 2/3.
2/3, thank you, there you go, okay, I was gonna say.
Uh-oh.
3 halves.
Okay,
I like
okay,
that.
I see. Alright, yeah. Yeah, okay.
It does work every time.
That's easier. I like
like
that one
that.
better. I like that one better. Okay.
All right, I feel like it does, like you do run into, I feel like there is
There's
something.
I'm
that
just thinking in
kind
my
of
head that there's somewhere that
I can't remember what. There was like some weird thing that kind of happens, but I can't remember what it was now, so good luck, you know, no, yeah, so.
Alright, yeah, I like that one. That one's faster.
But there's your answer.
And sometimes you don't put the number, like, sometimes you leave it like n minus 6, n minus 1/2.
Right, oh, okay, okay,
I forget what problem it's for, but it's just
right, yeah. So, but anyway, so there it is, it works, right? Get the same thing as you do here with the normal like product sum kind of dealy, all right? Remember also, another like situation we have, so let's say for example you cannot factor a quadratic, alright, so let's say you can't factor quadratic but you still want to maybe solve it, okay, what's like the ultimate thing that we have to fall back on?
Quadratic formula.
The quadratic formula, which is something...
I think that one should be called the trash formula, and
Right.
then the other method should be called what?
You don't name things.
What?
Yeah, Ryan.
No, I'm gonna scoot that down a little.
Sorry. So, we need to know this, okay? And you need to know how to use it, right?
B squared minus 4AC divided by 2x.
So this is used to solve a quadratic equation that is equal to 0. I'm just going to use the equal sign and 0 there, okay? Right? You can't use quadratic equation if it's like a quadratic equals 1, or a quadratic equals 3, or a quadratic equals 7, right? It's got to be equal to 0. Okay? If you have like x squared terms on both sides, you got to get all your terms over to one side and solve. But don't forget that. We need to be able to make sure you have that, use that, you know the quadratic equation, okay? It needs to be known. Okay? Let's see, I don't think. Yeah, no. Okay. There may be an example, although I have a practice test for you guys, and I think it might have a quadratic equation problem on it for you to do, I think. So, all right. Okay. Moving on. Here we go. So next one, difference and sum of cubes. This comes up very rarely. Very rarely, okay? I'm going to show it to you, but I don't feel like I really see it that much or at all on AP tests. But I'm going to show it to you anyway, just because. Okay? So, difference or sum of cubes. Here's how it works. Okay, I'm going to do both at the same time here, okay? So, this is x cubed plus or minus y cubed. All right, so two cubed terms there. That's equal to x plus or minus y. So this first one is like the, you know, the uncubed version of x, the uncubed version of y, and it keeps the sign. Okay, and then the next one is the squared version of x, the opposite sign, so minus plus, right? So if you had it was x cubed plus y cubed, this part here would be x squared minus then, okay? And then the x part times the y part plus the y squared. Okay. If you guys had Mr. Beal for pre-calculus, he used SOAP.
Same, opposite, always.
Yeah, so if you have your sign here, it's the same sign, opposite sign, and then always positive is the other. This is the third sign there. SOAP. Same, opposite, always positive. Okay. Do you want to add that to your list of mnemonic devices to help you remember that? That's fine. Okay. Oh, Mr. Drum had another one? Okay, gotcha.
Mrs. Steinfeld just kind of said you need to know this. So.
There you go, that's right. You will know this!
You have to know this.
That's
You better
it.
remember it or you're going to
Okay.
fail at life and take stats.
So let's do this first one. Okay. So our x cubed term is x cubed. Okay, so in the first little set of parentheses here, okay, what's just x going to be? It's just going to be x, right? Okay, so like x cubed, we just have the uncubed version, so it's just x. So x cubed is just x. And then what about our sign? What's that going to be? Plus, right? Keeps the same sign there, right? That first one. And then what's our y going to be? Yeah, 3, right? 27, remember, is 3 cubed. So this is a sum of cubes here, so it's x plus 3, right? And then that's going to be x squared minus, okay, and then x times y. So x is x, the y was 3, so it'll be like 3x, yeah? And then plus, and then what should go right here? And 9, because again, the y is 3, but it's going to be squared, so it gives us 9. Okay, so there it is. Nice and
then should we factor it? If we were going to keep going, should we factor x squared minus 3x plus 9?
I don't think this will ever
factor. Maybe it will.
I don't think it will.
Oh, ever in these problems?
I don't think it will be able to. I can't prove that, but I believe I could prove it. Maybe I thought about some, but I don't think this other one will ever factor.
Okay.
Additionally, like extra. I don't think so. All right. Let's try one more here. 8n cubed minus 125 y cubed. Whoa. Okay. So this could be a difference of cubes, right? Could be a difference of cubes. Probably is, because Mr. Whitmire already showed us a sum of cubes, and we're in the difference and sum of cubes section. So certainly he would not try and trick us. No. I would never trick you guys. Okay? So that's right. So there's our setup, right? So then our first kind of set of parentheses here, our first little part. What's going to be this first term here?
No, it's going to be 2n.
Yeah, so I hear just n, I hear 2n, I hear 8n. It's the quantity, it's 2n, right? Because this thing, okay, we could rewrite as the quantity 2n cubed, right? And then minus, and then what's this second thing? It's 5y quantity cubed. So then here it'll be 5y, and the sign is going to be same, so it's, sorry, minus. That was my, saved it, right? I did not make a mistake because 2n minus 5y, sorry. Okay. Cranky. Alright, and then we go into the second part here, our trinomial part. So it's the x squared, so that 2n is really going to be a what? 4n squared, yeah. Okay. Now opposite sign, so plus. And now it's going to be xy. So what will that end up being? Yeah, 10ny or yn, depending on what order you like it in. Okay. Plus, and then y squared will be 25. Y squared. There it is. That is it factored. I don't think this second one will ever factor.
No,
I don't think it ever factors. Okay. I don't think it does. Okay. Alright. Next. Other big type of factoring we should be able to do, GCF. Okay, greatest common factor. In fact, when it comes to factoring, that is the first thing you should do when factoring or simplifying, right? Always factor out that GCF.
Isn't this also like the easiest way?
Yeah.
Unless your play goes super complicated.
It helps because it then makes the numbers smaller, makes things easier to do, easier to digest.
Yeah, it's like basically mistake versus by mistake.
Exactly, right.
Show them the mistake.
Good analogy.
You want to take, because it just makes it easier for you when you're doing the math and stuff. So all right, let's try one here. 2x cubed plus 10x squared plus 12x. Okay. Now, the good news about a greatest common factor is that you don't have to, you don't have to pull out the greatest common factor first. So, for example, if you maybe, look at this and you're like, oh, okay, all these numbers are divisible by 2, and so you only pull out a 2. Right? If you only pull out a 2, you can then look back through this and see, oh, wait a minute, there's some more stuff I can pull out, right? What else can we pull out here? An x. And so then you go ahead and just do that, right, along with the 2. And you still end up then, and now I can see, okay, I pulled out all the stuff I can, and now that's the greatest common factor there. So you don't have to do it all at once, okay? And sometimes it's helpful to not do it all at once because maybe it's too much stuff to have to worry about. Now here it's not so bad, right? But in other larger problems maybe or something, you might have more stuff there, and if you realize you missed something, then just pull it out and take another step to pull out the rest of it, okay? Okay, great. But this actually factors more. So there we go. Which is not a GCF there, but I decided because we're in factoring, why not extra factor there too. So there you go. Okay. It's 2x, x plus 2, x plus 3, x plus 3, x plus 2. All right, you guys try one. Okay, so factor as much as possible. Okay. So let's see here. 10x to the 4th minus 55x cubed plus 60x squared. Well, there you go. Give her a go. Give her a shot.
Should we like use the quadratic formula if we get it down to where we can't factor it anymore?
Let me see here.
Sure, need to.
if you get stuck, I think you could use the quadratic formula. It's a little bit tricky to use the quadratic formula to factor exactly, but could you factor that?
Yes.
Well, 5 times 5 is 10.
Oh.
Oh, what? 5
Oh,
times 5
whoops.
is 10.
There's my problem.
What? That's the 20. I'm not doing this.
I thought 5 times 4 was 9.
What? Was that 19? 21. Stop!
My bridges last year did not do very well, and I think it's because I used like kind of like crummier straws or something. I don't know. They didn't do very well. They did all right, but not great. I don't Okay, so here's what we should have gotten, yeah? 5x squared, 2x minus 3, x minus 4.
I did it.
Okay.
It took me a while.
There's one last little strategy that we want to be able to use or to utilize, and that would be grouping, factoring by group. Oh, actually, any questions so far on any of these? All right, it's all pretty straightforward, easy. All right. Like I said, last one is grouping, and this one's going to be fairly useful to us. We're going to see some pretty complicated factoring by grouping as we get into calculus. It's going to involve like factoring things with like square roots and stuff like that. But if we can get it down, it'll be really useful for us for our simplification and stuff like that. So, you know, yeah, and I'll show it to you I'll point it out to you when it comes up, of course. All right. All right, so it's already kind of factored here, you know, in pieces, I guess I'll say. In a way, it's already kind of factored. But we have some further factoring we can do, right? So, for example, I mean, what's a common factor here we can kind of pull out? So, yeah, we can pull out an x plus 1. In fact, how many x plus 1s? There's like, we have an x plus 1 squared there, right? And there's a cube here. So this term has 2 kind of x plus 1s being multiplied together. This term has 3 x plus 1s being multiplied together. The most you can pull out, though, is x plus 1 squared, right? Because that's what they both have in common. They both have an x plus 1 squared in common there. Okay? Likewise, they both have some x plus 3s. This first term has 3 being multiplied together. The second term has 2 being multiplied together. So what's the most we can pull out then? We can pull out 2 of them, right? Squared, okay? So it'll be x plus 3 squared. Okay? And so what does that leave? Well, I'm going to kind of use like a square bracket here to kind of then indicate the leftovers. So from this first term, what's left over?
Just 1 x plus 1.
Just the
x plus 1.
Well, let's see. We pulled out 2 x plus 1s though. So what's left over? That we have an x plus 3 left over from that first term.
Okay.
From the first term, we have an x plus 3 left over. From the second term, is there anything left over? An x plus 1. Okay, and now I can do just a little bit more simplification because these two things have some like terms we can combine, right? And so it ends up being x plus 1 quantity squared, x plus 3 quantity squared, and then I'm just going to use now outside of parentheses, what, 2x plus 4? So you can pull out a 2 if you wanted to. As far as like pulling out like a GCF that's just a number, that's up to you whether you want to pull that out or not. I'm just going to leave it in. Yeah. So you can factor the 2 out here if you want to and pull it all the way out front if you'd like. I'll just leave it because, yeah. But yeah, absolutely you could pull out a 2 there. You absolutely could pull out a 2 there.
Where's the 2x plus 4 from?
So again, we have 2 terms being added together here, right? Okay, so we saw between these 2 terms, right, we could pull out x plus 1 squared from each term, right? And we could pull out an x plus 3 squared from each term. And then what's left, though, right, we said the x plus 3 was left over from here, plus, right, the x plus 1 was left over from here. And so we can combine those together. X plus x is 2x, 3 plus 1 is 4. Okay, so they're kind of like the leftovers. So there it is.
Multiplied, but they're not.
Yep, no, because again, we had addition between the 2, so it was addition there. We added them up. We're leftovers. Okay. All right, we'll do one more here. All right, let's see. This one's kind of long. Let's see if I can fit it in. So 3 times 2x minus 1 cubed times 5x plus 4 squared. Yep, okay. Times a 2 at the end. What? Because why not? Plus 2 times 2x minus 1 cubed times 5x plus 4 times 5. Like so. And now that I'm thinking about it, I don't know if this is really right for me to call this factoring by grouping. I don't really know what this would be called, but I don't think it's really factoring by grouping. Normally factoring by grouping, you have a long polynomial, and you just take maybe 2 of them, and then another 2, and you factor out that way. So this is not really factoring by grouping, but no, well, I don't know what we call it otherwise here. Okay, so again, we got to look through this. We have quite a few terms here, don't we? So let's see. What are some things you can pull out here?
Well, first can we combine like terms with like the 3 and the 2?
So yeah, if you want to, first step we can multiply the 2 and the 3 make take 6. Okay, that's one thing we could do there. And then also the 2 and the 5 to make 10. Maybe it just makes it a little bit easier for us to have that. Okay. So yeah, so what's something we can pull out here? Okay, so a 2. And then what about 2x minus 1s? How many 2x minus 1s can we pull out? The 3, all cubed right there. We can pull the whole lot of them out. Okay, what about 5x plus 4? Just one of them. So all those are factored out. I'm going to again use, I like to use the square brackets for the grouping symbols when we do our leftovers. Okay, so what's left over from that first term then? A 3, and anything else? 5x plus 4. Okay, so that's like the leftovers there. And then plus, and then what's leftovers from this first one? Leftovers from the 10, a 5. Are there any leftovers from 2x minus 1? Nope. And the 5x plus 4? Nope. Okay, so there that is. And again, we can do a little simplification here. And so you get 15x plus 12 plus 5. And then finally, combine the 12 and the 5, so you get 15x plus 17. Okay, and there it is. Wow. Okay. Pretty intense, but there it is. Okay. It's much easier to have something written. Now, why do you even bother doing this, right? So it's much easier when you have something written in this way to then cancel out. So if you can imagine if this were like a fraction, like if we had this and then over a bunch of things too, it's much easier to cancel out this way than it is to kind of cancel out this way, because you'd have to like split the fraction up over the addition and stuff like that. But when you have it all as like some products, the products are much easier to cancel out. And then we have that addition, and addition really complicates things. Okay. So there you go. Okay. Any questions on factoring stuff? That's it. That is it. So we'll stop there, and I'll give you guys your assignment. The assignment is going to be a worksheet here with some factoring on it, so you guys will have